Okay, we're going to have a little look at compound interest. This is also known as appreciation, where we looked at depreciation in the previous exercise, where the value is going down. Now it's going up, so it's appreciates. So this might be buying some sort of an investment where the value goes up. You might be buying a house, you might be buying an expensive painting, anything really, or you might just be putting money in the bank into an investment account that earns compound interest. So the initial amount you invest is called the present value, PV, or the principal, which is just P. We're mostly going to be using PV. How much it's worth after time is the future value, or FV. So let's look at these examples. So firstly, find the future value of a $5,000 investment invested for 3 years at 8% per annum, compounding quarterly. Okay, so at the start, it's $5,000. That's how much we're investing. Our rate of interest. Now, because it's compounding quarterly, we don't use our 8%. We do want to know how much our rate of interest is per quarter. So it's going, 8% is 0.08, so remember we use decimals. Divide it by 4 to get it into quarters. Okay, so that's 0.02. N is the number of quarters. So 3 years, there are 4 quarters in a year, so times that by 4, so that's 12 quarters. Okay, so after 1 quarter, we've just got one lot of interest on. So it's just 5,000 times, now it's not just times 0.2, we're adding it on. So you've got 100% plus the 2%, which is 1.02. Okay, so 100% plus 2% interest is 102%, or 1.02. So be a little bit careful with that. We have to increase it by 2%. So after 2 quarters, you get that answer, whatever that is, 5,000 times 1.02, and that answer would get multiplied by another 1.02. So you can see the pattern here. After 2 quarters, you've done that twice. So after 12 quarters, you would multiply by 1.02 12 times. And you can put that into your calculator. And that's $6,341.21. You may also be asked what the interest is in that. The interest is just minusing the 5,000 off that you started with. So 6,341.21. Now we weren't asked for that here, but I'm just doing it anyway. So $1,341.21 interest. Okay, we can also use that using a table. Now your textbook provides you with this table, and an exam may give you this table as well. That is a table of future value interest factors. Now essentially what that is, these numbers, are just this. Okay, so the one we're looking for here is when we have 2% for 12 quarters. So this number right here, 1.2682. So our future value interest factor is 1.2682. So that's the same as this, just rounded off to 4 decimal places. So to find our future value, we just do our 5,000 times our 1.2682. Now, you don't actually get the exact same answer because of that rounding. You do get the answer 6,341. So you're missing that 21 cents just due to the rounding. Here are the page numbers for that table. Okay, here's another question where we're looking at how much to invest at 10% per annum for 15 years, compounding annually, to save $20,000. So we want our future value to be $20,000. We're asking how much our present value should be. So this is basically the formula I used up here. You have your present value multiplied by that value in the table will give you your future value. Anytime you're doing any of these questions, I suggest you write down off to the side R equals N equals. Now this is compounding annually, so we can simply use these values we've been given. It is 10% per annum, that's annually, as long as it's R and N must match, and it matches with whatever word is here. So the previous one was quarterly, R and N had to be in quarters. this one is annually, so R and N have to be in years. So our N is 15 years. So if we look on the table for 10% and 15 years, okay, we've got 10% up here, 15 years here, this number here, 4.1772. So our PVIF, our present value interest factor, is that number, which was 41772. And if I did present value that I don't know times that number, it has to equal this 20,000. That 20,000 is our future value that we're trying to save. So obviously we just divide each side by this 4.1772. So the present value is 20,000 divided by 4.1772. And if you put that in your calculator, we need to invest $4,787.90. Now, just something interesting here. It's fine just to round like you normally do here. If we'd rounded down, this value may have actually ended up being a few cents short of the 20,000. In this case, it was actually rounding up. But yeah, rounding down, technically in real life, it's not quite enough. But you don't need to worry about that at this point.